Good morning. Now today we will talk about the absolute value of a rational number. So what is the absolute value of rational number that we are going to discuss? Absolute value of rational number. Now see, before we come up to the absolute value of rational number, we will understand that what are the absolute values of the integers. Now if suppose I take -2, I take 0 and I take 5. These all are the integers, right? -2 is a negative integer, 0 is also an integer and 5 is also an integer. 5 is the positive integer. Okay, so I have a negative integer 0 and positive integer that is 5. Clear? Now what are the absolute values? Whenever you are asked to find out the absolute values, these numbers are written in these two lines. These lines are known as mode. What do we call them? Mode. Clear? Now when you call them mode, what is there? You are supposed to find out the absolute value. Now, when we say the word absolute value, it is nothing but the positive value of every number, regardless of the sign. That means the magnitude will remain same, but whatever sign is there will always be changed to only positive sign. Now, if I have to write the absolute value of -2 in mode, it will always be 2 without mentioning even the positive sign. You do not have the need to mention the positive sign. Only 2 is the absolute value of -2. When we talk of 0, the value always remains 0 because 0 is itself at the point of neutrality, that means at the middle point where it does not have any kind of positive and negative sign. So automatically the value, that is the absolute value of 0, comes to be 0 only, right? Now when we talk of mode 5, clear? Now 5 is already a positive number. When this 5 is there, that means it will also be converted to its positive value only, regardless of the sign. So absolute value means converting the number into the magnitude term only, regardless of the sign. That means we do not consider what sign was being assigned to that particular number. We only take into consideration the numerical value. Okay, that means the magnitude of the number is only present or exists as the absolute value. Now when we have to convert them into the rational numbers, or when we talk of the absolute value of rational number, obviously we all know that the integers are representing the rational numbers in P upon Q form. Right? Now if suppose I have -1/7 in the mode. So what is it? It is a negative rational number. What is -1/7? It is a negative rational number. Now when you have to find out the absolute value, obviously these mode will get away and 1/7 is the absolute value regardless of the sign and regardless of what? Regardless of the mode lines, and the negative sign is also removed. Clear? Then we have 0, because 0 is also a rational number. Again the value, that is the absolute value of 0, remains 0 only. When we talk of 2/5, it is a positive rational number, right? Now positive rational number here says that its value will be 2/5 only. So whenever we talk of these numbers, that is the negative rational number, 0, the positive rational number, their absolute values are always the positive values regardless of their signs. Is it clear? Now we come to the next topic. That is, we will talk about the properties of absolute value. Clear? Properties of absolute value. The first property that says that whenever we have two absolute values combined together, their absolute value will always be 0. Suppose I have one rational number p upon q, the other one is r upon s. Clear? Now, if these both numbers are kept inside the mode r upon s, right? Now you are going to solve it. Suppose this is 1 upon 2, this is minus 1 upon 2. So we all know the absolute, the value inside the mode will come what? 0. Now when you get 0 inside the mode, its absolute value is 0 only. Clear? Now if I have two rational numbers p upon q and r upon s, or you can say that p upon q's form is only with the negative sign, right? Instead of taking some other different rational number, let's take minus p upon q only. And when these two are added or compared in any sense, we all know that these can be considered as the positive and negative rational number with same digits or same numerical magnitude, right? So 1 upon 2 minus 1 upon 2 is equal to 0 inside the mode, and when it is outside the mode, or we say that the absolute value of 0 is 0 only. This is the first property that we have learnt just now. Let's come to the next property. The next property, I have already explained that whenever we talk of 0 as a rational number, then the absolute value of 0 is always 0. So, second property says if 0 is the rational number, then its absolute value is 0 itself. Clear? It is 0 itself. Now, the third property that we will talk of is about the two rational numbers, which says that any rational number, if you take any rational number either with a positive sign or a negative sign, it doesn't make any difference. The absolute value can never be a negative value. Okay, your absolute value will always come in positive. Absolute value of any number, be it is an integer or it is a rational number, the absolute value of each and every number is always positive. It is never negative, right? So the third property says the absolute value of a rational number be it is a positive rational number or it is a negative rational number, the absolute value remains 0. The absolute value of a rational number, be it is a positive rational number or it is a negative rational number, always comes to be positive. Okay, it is never negative. Clear? This you have to keep in your mind always, that whenever, if suppose sometimes it is there that inside the mode the numbers are represented in different forms, but you do not have to worry, because whenever this word absolute value has been asked to you, you have to always keep in mind that you just have to change the sign of the given negative number to positive if it is negative, otherwise let it be as it is. For example, I have just explained, if your rational number is minus 2 upon 5, if you are talking of its absolute value is 2 upon 5. Now suppose this negative number is not present here, then also the absolute value is 2 upon 5, because it can never be in negative. It can never be in negative for any of the rational number which are known to us. Now we will talk about the next property. Now let's come to the next property. The next property of absolute value says that whenever the two rational numbers are added, then there is a difference in the absolute values of the two numbers. Let's see how. Suppose I have P upon S and Q upon R as the two different rational numbers. Now they can be represented in two different manners when we talk of the addition. How? There could be one condition where P upon S plus Q upon R is inside the mode. Clear? And P upon S is in the mode plus Q upon R is in the mode. Clear? Now, out of these two, which one is greater? This one will be always, this representation or this form of absolute value will always be greater than equal to this form of the absolute value of two rational numbers. Now let's take two rational numbers here. Suppose it is 1 upon 2 and this is plus minus 3 upon 4 inside the mode. I took the LCM 4, this became 2 and this became plus minus 3 inside the mode. Now when these two signs are there, it will be minus 3 and this will be 2. So I will result in minus 1 upon 4. Okay, inside the mode. The absolute value of minus 1 upon 4 will be 1 upon 4. Let's see what we will get this side. This is 1 upon 2 in the mode plus minus 3 upon 4 in the mode. Absolute value of 1 upon 2 is 1 upon 2 only. Absolute value of minus 3 upon 4 will be 3 upon 4. LCM will be taken as 4. This will be 2. This will be 3. The answer will be 5 upon 4, which is greater than. Now when you will compare 1 upon 4 and 5 upon 4, obviously this one is greater than 1 upon 4. Now here look, this form of representation of the rational numbers, both the rational numbers were inside the mode lines, and here the two different rational numbers were in the different mode lines. So you are supposed to first find out the absolute value, then add the following rational numbers. And here when you are talking of the finding the absolute value, first you will calculate their sum and then you will find the mode, or you will remove the mode lines and write the absolute value. So this is the difference between the two. Now let us come to the next property, that is of multiplication. Now if any two rational numbers are multiplied with their mode values, or you can say with their absolute values, or their absolute values are calculated after doing the multiplication, how does it make difference in the two cases? Similarly, I will write P upon S multiplied by Q upon R inside the mode lines, and I will write P upon S multiplied by Q upon R, but separately in the mode lines. Now what will happen to the two calculations or in the process, let's understand. I will take the same numbers, 1 upon 2 multiplied by minus 3 upon 4 inside the mode. They will be simply multiplied minus 3 upon 8. Clear? Its absolute value will be 3 upon 8. Fine. What I did, P upon S, Q upon R are two rational numbers. Then P upon S, the value of P upon S is 1 upon 2 as I have taken. Q upon R is minus 3 upon 4. When these were multiplied, I got the result minus 3 upon 8. The absolute value of minus 3 upon 8 is 3 upon 8. That is in positive. Clear? Now P upon S multiplied by Q upon R. Now first we will find out the absolute value, then we are going to multiply these two numbers. Here first the multiplication has been done, then the absolute value has been calculated. In the second process, firstly we will find out the absolute value of each of the following rational number, and then we will find their product. So let's see, P upon S is 1 upon 2 inside the mode, multiplication sign, minus 3 upon 4 inside the mode with a negative sign. Clear? Now 1 upon 2 will be 1 upon 2 because the absolute value of a positive rational number is always positive. Multiplication sign will come as it is. Then this is minus 3 upon 4, which talks of that this will be changed to 3 upon 4. Now let's multiply. 3 upon 8. Clear? Now you can see 3 upon 8 is here, 3 upon 8 is here. That means in both the cases, whenever there is a multiplication between the absolute values of the numbers, or if you are finding the absolute value of the product of two rational numbers, they are always same. So that means I can state here that whenever any two rational numbers are multiplied and we find out their absolute value, or the multiplication of the absolute values of two numbers is done and the resultant product, these two conditions are always equal. They are always equal. Now let us come to some of the examples related to absolute value. Now let's look at some of the examples which are related to the topic which we have just now discussed, that is absolute value of the rational numbers and their properties. Now in the first case, the question says verify that mode P is equal to mode minus P. Right? Now you have to find out whether the result of these two conditions is same or not, whether the LHS is equal to RHS or not. The value of P is given to you as minus 3 upon 10. So let us note the value of capital P, that is minus 3 upon 10. Now let's take only the left hand side. The left hand side has P. Okay. Now the value of minus 3 upon 10 is equal to what? It is equal to 3 upon 10. Right? Now what I have done here, the P's value, that is minus 3 upon 10, has been substituted here inside the mode and I have calculated the absolute value. We all know that the absolute value of a negative rational number is always positive, right? So this has come here, minus 3 upon 10 has been changed to its absolute value, that is 3 upon 10. Now let's take the next condition. The next condition is of minus P. Now how are you going to represent it? Minus sign outside, inside the bracket 3 upon 10 with the negative sign, mode lines closed. Clear? How are you going to represent this minus P? Minus P is not the sign of the 3 which is already present here as a negative sign. Here the p's value has a negative sign. So the value of p has been written inside the bracket and outside it this negative sign has come. Now let us see. It comes to be 3 upon 10 inside the mode and outside the mode also it is 3 upon 10. That means these two values here are same. Clear? Now there is no difference in the absolute values of the rational number in whatever form it is written, whether it is in the form of mode p or it is in the form of mode minus p. Clear? So the absolute value remains the same. Now let's come to the next question. In the next question, you just have to write the absolute value of the given numbers. So let's take number 1, that is minus 5 upon 9. Therefore, mode P is equal to minus 5 upon 9, that is 5 upon 9. Is it clear? Again, the negative sign has been changed. We all know that absolute value cannot be in negative sign ever. So always it is a positive value of the given rational number. Regardless of the sign, only the magnitude of the rational number is considered in the absolute value. Clear? Then we have B, which is 2 upon 7. Therefore, inside the mode lines, 2 upon 7 inside the mode lines, the absolute value is 2 upon 7. Let's take the third question, that is 0 upon p in the, it is 0 upon 8, p in the mode lines, then 0 upon 8. Now first you are going to divide this. We all know that whenever the division of the rational numbers is done, if 0 is the numerator, the quotient comes to be 0 only. So this will be mode 0 and the absolute value will come as 0. So this is how you find out the absolute value of the given rational numbers. Now let us come to the next question. The next question again talks of the verification of the property, that is mode A plus mode B is greater than equal to mode A plus B. Clear? So this is what we have to solve. First of all, we will write the values of A, B. That is A is 7 upon 3. B is equal to minus 2 upon 5. Now let's see. We will take the first condition, A plus B inside the mode. This is greater than A plus B inside the mode. Now let us take 7 upon 3 plus minus 2 upon 5. We will solve this condition first, that is the LHS. Clear? Now 7 upon 3's absolute value is 7 upon 3 plus minus 2 upon 5's absolute value is 2 upon 5. I took the LCM as 15. Clear? Here when I divide 15 by 3, it goes 5 times. 7 into 5 is 35 plus here it goes 3 times, 3 2s is 6. So the answer which I get here is 41 upon 15. Clear? 3 and 5's LCM is 15. This 15 when divided by 3 goes 5 times. Multiplied by 7 gives you 35. And here 5 divides this 15 3 times. When this 6, how do we get this 6 here? The 3 multiplies 2 and we get 6 here. Then when these two are added, we get 41 upon 15. Now let's come to this condition. Here we will write 7 upon 3 inside the mode plus 2 upon 5 with the negative sign. So I can change it to, for my convenience, it is 7 upon 3 minus 2 upon 5. Clear? inside the mode, because plus and minus sign gets changed to minus sign. Fine. Now after taking the LCM, that is 15, what I am doing, I will be changing the numerators. Here I will get 35 and here I will get 6. Clear? 35 minus 6 will give you 29 upon 15, but inside the mode value. So ultimately your absolute value is 29 upon 15, which is not at all equal to 41 upon 15. So we come to a conclusion here that 41 upon 15 is greater than equal to 29 upon 15, or it is greater than. Here greater than equal to this is the standard condition which you can observe. Either it is greater than or it will be equals to, but it will never be smaller than this condition. Okay. Now let's talk of the multiplication of these two numbers with the different conditions. The values are same. Now for multiplication, A multiplied by B in the mode, then A multiplied by B with different mode lines, right? Now the condition is saying that these two should be equal. Now let's put in the values. 7 upon 3 multiplied by minus 2 upon 5, that is this. Here we'll do both these situations simultaneously now. Multiplied by minus 2 upon 5. Now see, what is the difference between these two? The difference between these two is that first here you are going to find out the product, then you will find the absolute value. And here, as I have already explained in the earlier example also, you will first find the absolute value and then you will find the product of these two numbers. So please do not get confused when you get such type of questions. You just have to look that in what condition you are supposed to calculate the absolute value. Either the product has to be calculated first or the absolute value has to be calculated first. Then you have to move on to the multiplication of the two given rational numbers. So let's solve this now. 7 multiplied by minus 2 will give you minus 14 upon 3 5s are 15. Clear? Now its absolute value is 14 upon 15. Clear? Now 7 upon 3's absolute value is 7 upon 3 multiplied by minus 2 upon 5's absolute value is 2 upon 5, and when these two are multiplied we reach to 14 upon 15. That means these two conditions are equal. So that is all for today's session, and now we have completed the chapter rational numbers. You all have to go through the exercises given in the book and practice them. Thank you.